Okay. Hey, Roland, Meredith, thank you so much for joining us today in this HoloCast, a combination of a hologram and a podcast. And Roland, Meredith, please let us know who you are, what do you do?
Who you are and what can you do?
Yeah. Who are and what do we do? Do you mean me personally? You want me to give my introduction to myself? You're asking about TXRX. Can you?
Um, Tell me, tell me what's the XRX Labs, and then what is your role, please?
So,
What task and what's the role?
we're TXRX Labs. We're a nonprofit. We do innovation, job training, and community outreach work. We do prototyping for folks to help with physical innovation, and we use that work to provide apprenticeships for at-risk youth. And we also allow the public to come in and take classes and get training on some of these areas so they can also know how to work in the same innovation areas we work in.
And I'm Meredith. Sorry, I thought you said both of us. I'm Meredith. I'm an industrial designer. I also work here. That's also my cause. I'm in the engineering department. I'm also an educator. I teach a lot of the classes here, and I just help with general support and prototyping.
Interesting. So, what is additive manufacturing? What's 3D printing? Sorry. Yeah, what is additive manufacturing? What is 3D printing?
I'll let you take this one. You're the industrial designer.
Additive manufacturing is the process of you're adding something, so starting with nothing and adding to it, versus subtractive, where you have a material and you're subtracting or taking away from. So 3D printing is a type of additive manufacturing.
Why this is different from traditional manufacturing? So I can use 3D printers versus use traditional machines. So what is the advantage of using this 3D printer behind me?
You want to take that one?
I'll take it. The advantage is that 3D printing can speed up some workflows, and it, in a way, reduces certain aspects of labor because it's designed in a computer. It still takes the skill set of the modeler to design something that can be fabricated, but it may speed up some processes because it's faster to make iterations. It could be cheaper as well.
And what's about the quality? It's cheaper, but can you produce a model using a 3D printing machine and the quality is going to be as good as using a traditional machine?
3D printing does produce high quality parts. It kind of varies though. When you say try traditional means, it very much depends on exactly what the geometries, materials, and requirements are. But yes, in general, at least for model making, 3D printing produces parts which are in some ways superior to the parts that were produced with traditional model making techniques. But that's not necessarily the case if you're talking about other traditional manufacturing techniques, for instance, machining or injection molding or areas like that. 3D printed parts are generally still probably inferior to those types of parts. So it really very much depends upon the, specific area that you're working in and process you're trying to achieve and the part that you're trying to produce. So it's hard to say that from a very generic standpoint.
Great. 3D printing has been in use for a couple of years, but how do you forecast the future of 3D printing?
How do you forecast the future of 3D printing?
That's a tough one. 3D printing is received a lot of adoption within different markets, but it still struggles from a number of, I guess what you'd say, pretty serious, hurdles. So I think that if those hurdles can be overcome, then 3D printing may be able to achieve, I think, I guess I would say, more widespread adoption. But until it can achieve the same sort of cost efficiencies, the same sort of material availability, and the same sort of tolerances and surface finishes as traditional processes, it's probably going to continue to be relegated to prototyping, small batch production, and kind of more niche markets. There are a lot of niche markets where 3D printing is quite useful. They make Invisaligners with them. They make custom helmets for the NFL and stuff like that. But those are what I would say are one-off applications, right? People are not producing things that are generally produced at large scales very often with 3D printers, unless they're just doing it as a novelty, to be honest with you. So I think that we'll have to see if the 3D printing R&D can overcome those hurdles. Otherwise, I kind of foresee, 3D printing has not only been around for a couple of years. 3D printing has been around for, I think, 30 years now. Very early 3D printing, I think, was going on even in the late 80s. And so we're a good 35 years into 3D printing. So it's not like it's a totally new, novel market. It has matured a lot during that time with a lot of different technologies, a lot of different use cases. So I think that we're kind of hitting probably a little bit of maturity for it. If I guess, FDM 3D printers have become commodity items, right? There's very high quality, relatively reliable, small scale FDM 3D printers you can buy for $500 to $1,000. So, the fact that those exist at those price points, and the fact that 3D printing has not probably exploded beyond where it is, I think does point to the fact that there still are some underlying technological hurdles that have to be overcome before it gets more widespread adoption.
Interesting. What kind of materials can you use using the 3D printers? If it's only plastic,
everything from resins,
like titanium. What kind of materials can
resins, thermoplastics, metals. There's all sorts of binder jet applications where you can put together any type of material generally and bind it, right? So it kind of depends on the technology that you're using, what your materials are, right? But there's pretty wide. People are 3D printing ceramics. They're 3D printing tissues. So the materials are pretty unlimited. I don't want to say unlimited, but they're very widespread at this point. It depends on the technology you're using and what your goal is.
Now, I heard that with 3D printers, another advantage is if I produce a prototype, it's repeatable. It's something that I can repeat like 1,000 times, and the prototype will look exactly the same versus trying to use a manual technique, like just craft it with my hands or with machine tools. I believe 3D printers can help you to create a repeatable process. Is that right?
Yes, that's true, because it's a machine process. It's designed once, or it can be, you can run tests on it. It's easier to be more precise in a digital environment, so you do take that hand-making element out of it.
What was the question?
Saying that he asked, is it true that you can make multiple copies of 100 of one kind of thing? Iterations.
Oh, you iterate with 3D printer faster? Okay, sure, yeah.
Versus, I guess, if a skilled crafts person were to do it, every time there can be a chance of it.
Are you asking if 3D printers are better in compared to manual processes, or are you asking if 3D printers are repeatable?
Both. If are better and is repeatable.
Repeatable, yes.
Well,
Better
3D printer, it depends on what you mean by repeatable. Compared to traditional manufacturing techniques like press brakes, CNC machines, injection molding, stamping, forming, 3D printers are generally not very repeatable, actually. Most of those systems will hold tolerances down in the in the thousandths of an inch, right? And you're also dealing with materials that generally are much more homogeneous. With a 3D print, one of its biggest problems is you're extruding or melting or in some other way, forming your material. Because that process occurs layer by layer, section by section, and that often tends to introduce minor inconsistencies within the part. That's one of the biggest drawbacks right now of 3D printing is, great, I make a part, how do I know it's any good? How do I know there's not a hole inside of it? It's fine if you're making a model of a spaceship, but if you're making an actual spaceship, holes inside the rocket engines don't work real well. So they can't often make parts that are repeatable because very easily. And so that's where a lot of the research in 3D printing is going on, is like, how do I do things like using ultrasound, MRI, or other techniques to actually look at the parts and validate them, to ensure that there aren't defects hidden away inside of them. Under normal process, like let's say for instance CNC machining, I start with an ingot of material, right? That material has been forged or whatever, and I know that it's relatively homogeneous, consistent, and its material properties are sound. When I remove material from that, it doesn't change the underlying material properties. But when I extrude plastic, or when I take a bunch of plastic powder and shoot with a laser, any small inconsistency in that process affects the underlying material property. So if your question is more about, are 3D printers really good at making high quality, repeatable parts compared to traditional manufacturing, then I would say no, they're not, and that's one of their biggest drawbacks. If it's, can I make lots of copies without human interaction of a simple part, then yes, 3D printers are good in that fashion, and that they are a one-stop shop. You don't need a person with lots of manual processes or even lots of automated processes. The 3D printer is a one tool that does it all.
Good. So do you see this, like astronauts using this on the moon or on Mars? So you have a couple of astronauts on Mars and they need to manufacture a replacement component. Do you see that this is the future for them? Yeah. Do you see astronauts on Mars or on the moon using this technology to produce replacements or pieces in space?
As an application in space technology, actually
Yeah.
on space.
NASA's been working on that for a while. They've had 3D printers. I think they have a 3D printer on the space station, if I remember correctly. I don't know if it's really gone anywhere, right? They're going to 3D print tools. I think, not to be the fly in the ointment or the negative Nelly, but the technology just hasn't reached the maturity to produce the type of high quality parts that we often associate with the space program, right? You don't want to send someone out on a spacewalk and the tool they have breaks in half and stabs them, right? So you need, I'm sure every screwdriver that's gone up on a space shuttle has probably undergone 47 million tests, right? And so the question is, how does a 3D printer produce these type of parts that have high, quality requirements, high, tolerance requirements, right? It's not there yet. So I think there could be an area for it in the future, but I don't think it's there now. Just because you have lots of problems. Most parts consist of multiple different materials, and most 3D printers are not good at that. They cannot produce parts that consist out of multiple different materials. The changeover process between materials is time-consuming and difficult. So I think there's a lot of hurdles that probably really, limit it in terms of its use right now. You'd probably be better off with a small CNC machine and a bunch of different, cutters and metallic components than you would, I think, a 3D printer. Specifically also because most of the 3D printers right now just print plastics, and while that's fine for a number of applications, a lot of the parts that are used in space applications are metallic just due to the strength of them. Weight's not really that big of a deal in space anymore, right? Much better to have strength, probably. I don't know. but it looks like most of the parts also off gassing and other sorts of stuff. So I don't think it's there yet. There's probably more than you want to know about it.
For people watching this HoloCast, what if they want to buy a 3D printer and try this at home? It is expensive to buy a 3D printer. It is hard to use, or it's something that is affordable and easy to use.
Well, I'll speak for the technology part, just because I teach 3D modeling here. We teach Fusion 360 because it's an affordable entry-level software. I would say, yes, anyone can buy any technology, but I feel like most people who have purchased a 3D printer quickly find out that 3D modeling is difficult, or that is really what stops them from actually using their printer. It's having that background knowledge on. I mean, that's possible. You can learn all of that. Just figure out the correct CAD package that you want to use, and I'll let you talk about 3D printers.
What was that
He wants to know what is the hurdle to like stop people from adopting this technology at home? If people would 3D print at their house.
Value and free time. It's really just value and free time. I mean, what's to stop you from becoming a woodworker and building your own bed? Who wants to own a bunch of woodworking tools and build their own bed? We generally like to specialize in efficiency, right? You know, you let a woodworker with a shop build your bed, and you focus on, you know, developing holo applications, because that's what you're good at and that's what they're good at. Giving everyone a 3D printer, while it sounds like a really great idea, it requires all of them to become 3D printing technicians and 3D printing and CAD modelers, right?
Like servicing your dishwasher when it stops working.
Right. So I think that, you know, the problem with 3D printing to some degree is, you know, one way to think about it is like they have automatic milking machines. You don't own a cow in your house to get milk. You let someone else deal with the milk, right? And then you buy a gallon of milk. So I think the problem with 3D printers is it's the same thing, right? Like, it's just much easier to let someone who is skilled in it run it, and you get the outputs of it, and you be skilled in something. I think that's really what's going to stop the adoption of 3D printers at home. Now, that being said, there is probably a space for 3D printers at home, a little bit more for the educational market, right? So, you know, there could be a case to say that, you know, if you're teaching a child or teaching a class or a young adult about engineering, then having a 3D printer can be a very powerful tool to that. But I think that probably is a little bit different market than just, you know, everybody has a 3D printer in their home. And I think the other you know, market will be folks who want to innovate, right? It is a very powerful tool for someone who wants to create a new product. If you have an idea for a new, you know, something, and you buy a 3D printer, you can actually get a long way, if you're willing to spend the time, towards that prototype on your own, versus having to raise a lot of money and outsource it to other folks. But it does require a large amount of time investment. So it's kind of a sweat equity play, I guess I would say.
The limitation ultimately would, if learning it and enjoying it didn't stop them from moving forward with it, it would be a limitation of the materials that they can print with if it achieves whatever they're trying to make that prototype for. And then I would say the build volume, if that printer itself can build the geometries that they're trying to achieve. And all of that basically would be at different price breaks. If that is a home printer that they can actually have access to, or do they need to go outside and go to a company that has larger and more varied, different technology than what a home printer is.
Amazing. So, well, guys, thank you so much for your time. It's very interesting. I believe 3D printer is a topic that is of the interest of most of the people. This was a very good explanation. Do you want to send a final message, something that you want to say before we conclude it?
What would you like to say to everybody?
I guess I need to know, who is the target audience for this? Who's watching this?
It's going to be all kinds of people. People interested in technology, views about technology.
What would I say to those people?
What do you need a 3D printer for? And then do research to find out if what you're trying to make, that is the appropriate technology, the correct printer that you need. Does it make sense to invest in that? Do you have the time it takes and motivation to learn 3D modeling? If you don't get good at 3D modeling, then a 3D printer will never be useful for you if you plan on doing this technology at home.
what would I say to people? I would say that, 3D printing is just a tool, like any other tool. And if you want to be good at designing and creating new things, you need to have as wide of a range of knowledge as possible about what already exists. Because most everything that is invented is really just a slight change or a slight improvement on something somebody else already made, right? Even research that people do that's groundbreaking research is often predicated on the research of people that have come before them. We often don't spend our time learning about the knowledge that's out there to broaden our horizons. So I think 3D printing falls in that category. People don't want to learn about the means of production. They don't learn about how things are made anymore. We've lost that knowledge to actually mostly other countries, to be honest with you. If you think about where all the injection molding, where all the vacuum forming, where all the die casting, where all that stuff happens now, most of it has been moved overseas. I think that, the ability to learn about 3D printing, to learn about design and engineering, and then become versed in it to allow us to solve some of the most critical problems we have is pretty critical. I think that's what I would probably say to people is, they should learn about 3D printing not because they want to run a 3D printer. They should learn about 3D printing because, just in the same way they should learn about CNC machining, if they want to be intelligent designers, if they don't know the means of production, they will never be able to design for it. It's like a person building a house who doesn't understand nails. Probably not a really great house.
Awesome. Well, thank you so much for your time. It was great to have both of you here with me. Hopefully we can have you in the future. Thank you.